Domain and range of piecewise functions. So let's talk about what a piecewise function is. So there's basically two types of graphs. We have continuous graphs and discontinuous. Continuous graphs are these that they're all connected. So if we look, if I try to trace this graph, I can do so without ever picking up my pencil. I can trace all this graph. Yes, there may be some open circles and some dots, but for the most part, I can just trace it without ever lifting my pencil. Now, piecewise graphs are ones with gaps or they're broken. You have to lift your pencil to trace. So I can trace here, but then I have to pick up my pencil and push it here to get the rest of it. I can trace here, I've got to pick up my pencil, put it down to trace it some more. Same thing with this one. Curve, pick up, curve. These are all piecewise graphs because they're broken. Now, for the domain and range of piecewise graphs, we have a new symbol. We have this U. So this U is called a union. That's what the name of the symbol is. Now, we use it, so used to join, that's why it's called union, pieces of the domain or range. Pieces of the domain or range. Domain or range, but we only use this in interval notation. We do not use it in set builder. So this is only used in interval notation. So we use it to join pieces of the domain and range in interval notation. Okay, so let's see what it looks like on number lines before we start talking about two variable graphs. So if I have example 1, I have this number line. I want to write the domain in interval and in set builder. We're going to do interval first. So there's a piece of this graph that's broken. If I look, I've got a shaded area here, a broken and unshaded spot, and then I have the rest of the shade. So that's why we're going to need that union to bring together the two shaded pieces. So first, let's look at the left. So we always want left to right for domain. So my furthest left is going to be negative infinity. Then it stops here at 3. So that's the first portion of my domain. So we would have negative infinity to 3 with a bracket because it's got a solid circle, just like usual. Now here in the center, because this is where the break is, that's where we're going to put our union. So then we're going to join the other half. So the second half has a low value of 6 and goes on for infinity to the positive side. So we're going to have 6 to infinity. The 6 needs an open parenthesis because it's an open circle, and the infinities always have parentheses. And this is the final domain for this graph. So we've joined our two pieces. We have the left piece in red, then we join, we jump is what I like to call it, and then we have the right piece. Now in set builder, let's talk about how this would look in set builder. So of course we would have the fancy bracket and then x such that. And then so for our right piece, this is negative infinity less than x less than or equal to 3. If I translate that into set builder, I can't have this infinity sign, so all we have is x less than or equal to 3. Now, we don't use the u in set builder. Instead, we write the word or. Then we can do the right side. And so with this right side would be 6 less than x less than infinity. Drop the infinity sign, and we're going to have to flip this guy around. So we have x greater than 6. So in set builder, we use the word or to join our two inequalities together. Interval notation uses the union symbol. Set builder uses the word or. Let's look at number 2. Number 2 is in fact a piecewise graph. And the reason is because it's not everything between -2 and 7. If we look, I have to start at -2, jump over that open circle, and then continue on to 7. So we have to skip a number. It's not a whole section, but we are skipping something. So let's talk about how to write this in interval. So start at the furthest left, which is -2. Then we're actually going to have to end here at a positive 1. So the first section is -2 to 1. -2 is closed, so we're going to use a bracket. And 1 is open, so I need a parenthesis. Then I have to jump over the 1. I cannot include the 1, so this is where I'm going to place my union, is right here. Now on the second half, I'm starting at that same number. That's my low end of the other half, but I need another parenthesis. And then I have a stopping value of 7, which also has a parenthesis because it's an open circle. So basically, here's what this is saying. I can go from -2 and then as close to 1 from the left as I want, but I have to jump over 1 and then continue on to 7. So this is saying I can basically have every number between -2 and 7 except for 1. I have to skip over the 1, which is why it needed 2 separate inequalities, even though they both start with the same number. Let's look at how this would look in Set Builder. So we would have the curly brace, x such that, then we would have -2 less than or equal to x less than 1, okay? And there's no infinity there, so we can just write the entire thing. Then we have to jump, so write the word or, and then on the right we would have 1 less than x less than 7, and I don't see an infinity there either. And then that's it. There is another way you could write this. I said that I could have every value between -2 and 7 except for 1. So an alternative would be x such that, here's an alternative, I'll do it in orange, -2 less than or equal to x less than 7, comma, x is not equal to 1. That's another way to write it. These are both correct answers for the set builder notation. So I can basically have everything between -2 and 7, just not the 1. This is definitely simpler. It doesn't matter which way you decide to do it. Now let's talk with two variables. So we've got number 3. It says write the domain and range in interval notation. So be careful and make sure you're writing it in the correct notation that it asks for. So domain is our x's. So I need the furthest left to the furthest right. Well, the furthest left on my graph is this -10 here. And since I need the domain, I'm going to pull it up to the x-axis. Then I can trace my graph, and I move to the right, and then I hit this point, but there's no connection here, so I'm going to have a jump. So my first little section is here, between -10 and -2. That's my first little section. So we have bracket, -10 to 2 and a parenthesis. -10 was a closed circle, so it needs a bracket. -2 was a open circle, so it needs a parenthesis. Then I'm going to have to jump. So I'm going to jump, and I need my second half. Well, my second half starts right here on the x-axis. So that guy's x value is a -1. He's an open circle, so I need to put a parenthesis, comma, and then I can trace my graph to the right, to the right, to the right, to the right, and then I hit this point as my stopping point. And so my final end value is an x value of 5, 6, 7 with a bracket because he is a solid circle. So all of this is my domain. Now let's talk range. Range is the y's. So that's bottom to top, furthest down to furthest up. You may or may not use the coordinate points. So the lowest my graph goes is actually this little curve down here, not that coordinate point. So this curve has a y value of -7. And because it's a solid line, we're going to use a bracket. Now, if we look, if I use kind of up and down, if I look this way on my graph, well, I stop here and then I pick back up on the axis. So I'm going to have a stopping point, a jump, and then a starting point again. So let's see where my first stopping point is. So these 2 points are at the same height of -3. Oops, should be in red, sorry. These 2 points are at the same height of -3. Now again, I have a solid point and an open point. So when you have them double like this at the same height, the solid point wins out because you're allowed to have -3 somewhere on this graph. So we're going to have a bracket. This is where the jump is. So we're going to jump right here. This is our first section. Then we have our jump. And then our second section starts with these two at 0. Now again, I have an open circle and a closed circle. So the closed circle is the one that wins. And then the final highest point is this guy right at a 4. So this will be my next set of shade. And the 4 has a bracket because it's a solid line. So really we have two sections here. We've got this section of range, and then we have this section of range. Just like we had two little sections of domain. That was a section, and this one was a section too. Now let's look at 4. So let's talk domain for 4. And this one says we're going to write it in set builder notation. If it's easier to write it in interval first, then write it in interval first. Let's see. Sometimes that may be easier. So domain is furthest left to furthest right. So the furthest left, I see there's an arrow. Well, this arrow tells me two directions. This arrow tells me up, and it tells me left. So my graph is moving left forever. So down here on the x-axis, I'm going to put an arrow. And that's negative infinity. So my lowest value, I'm going to write it in interval, is negative infinity, comma. Now, if I move right, let's see what happens. I'm going to move to the right, and then I hit this point, I have to jump and go down here. But look, these are on the exact same x value. They're both at an x value of 3. So are you really skipping anything? Because this is a solid point and this is an open point. What that means is you're allowed to have the x value of 3 somewhere on this graph. So far, I'm not skipping anything. And then we can continue. So we're basically going to stop on this section, jump to this one, but I was allowed to have 3 here, so 3 is included. And then we can continue to the right and we hit another arrow. So again, this arrow tells me two directions, up and right. And so we're going to go right forever. And so that's a positive infinity. So on our domain, I'm going to shade in this everything in between. We have to remember that this little 3 was actually included because this guy filled it in. That guy filled in that 3, so that's okay. So that means I have all the values between negative infinity and positive infinity in my domain because that open circle got filled from this x value. I'm allowed to have 3 somewhere on the graph. Now let's translate that into set builder. So we have the curly brace, x, such that, now when you have infinities on both ends, that was your all real numbers. So we have x is an element of the all real numbers. When there are infinities on both sides, you have all real numbers. Now let's talk range. So I'm going to erase some of this blue so that we can see the range clearly. Here we go. So ranges are y's, so that's bottom to top. So the furthest down this graph goes is actually this little open circle right here. But I need this guy's y value, so I'm going to trace it to the y-axis, which is here at a y value of 0. And it's an open circle because 0 is not included, and there's no other 0 point there. Like I have no other solid point to help me close that open one. So 0 has to stay open and unincluded. Now, when you go up your graph, up is kind of weird. If I go up this side, I have all the values between 0 and infinity. Now, this guy starts at 2, but this little portion got filled in from the curved graph. So you're not really missing any values here. So our highest value on the y's is going to be infinity for sure, because this guy goes for infinity and so does this one. Oopsie, I need it in red. Sorry. Here we go. Highest value is infinity because of both arrows. So this left section starts here at 2 and goes up forever. This little right section starts at 0 and goes up forever. So those two pieces got connected together. So really there isn't a gap here either. This little gap got filled in with these guys' y values. So there's not a gap there either. So let's translate this into set builder. So we have y such that, now this is 0 less than y less than infinity, but I can't have this side. And we need to flip this over. So this is y greater than 0. And there's our set builder notation. Let's try a couple more. Example 5. Write the domain and range, and now we're back to intervals. So make sure you're reading and seeing which notation we need. So now we need interval notation. So I'm going to do my domain in blue again, furthest left to furthest right. So the furthest left is this coordinate point right here on the x-axis at -4, comma, and it's going to be a parenthesis because he's an open circle. Now, if I travel to the right on my graph, I'm going to travel right, right. I hit this point and I stop here at an x value of 0. And it's a solid circle. So far, this is my domain. Now, my next little section starts here with a solid circle at 2 and an open circle at 3. There's nothing here in the middle, so I'm going to have a union right here for my domain. So we've got -4 on the first section, and then all the way to 0 with a bracket, because 0 was a solid point. The union to represent the jump in between these two. And then my next section started off at 2 with a bracket and closed off at 3. And there would be our domain for example 5. Now let's talk range. So ranges are y's, bottom to top. So the lowest this graph goes is still that open circle here. So I'm going to erase some of my domains so I don't get confused. So that open circle has a y value of 0. So let's see what this, just the left section. So on the left part, the highest I'm allowed to go is 4, and that's a solid point. And so I have everything included in between. Now let's look at that little tiny piece. I start at a solid point of 2 and about, 1.5-ish, but there's a shaded part underneath this open circle's y value. So that means that's included. So really, there's not a gap here in the range at all. I go from 0 all the way up to 4. Everything's included in between here because that shaded piece here fills in this circle. And then so the 0 had an open circle, the 4 had a closed point, and there would be the range. So just because you have a gap in domain does not mean you're going to have one in range, and vice versa. You may not have a gap in domain, but you do in range. It just depends on what's solid and what's open. Last one, let's try 6 in set builder notation. I like to start an interval and go from there. So for domain, that's our x's, so I want furthest left to furthest right. Well, the furthest left, if I just look at this left little piece here, all I'm going to pay attention to is this right now, and then we'll do this piece separate and see if they overlap. So the left piece, I see an arrow, so that's going to move down and left forever. So on my axis, I'm going to do left forever to -infinity. Then the furthest right this little piece goes is right here, that solid point at a -2. So we're going to shade all that in. Now let's look at the right section. Let's see if I maybe have an overlap or if I have a gap. So the right section starts at here at a 2 with an open circle. And then again, all the way to the right is an arrow. So I go up and right forever. And so domain is the right, which is a +infinity. And I'm going to shade everything in between. So it looks like there's a gap in between here. I didn't have any x values to fill in that space. So that's going to be my union. So I'm going to write it in interval notation first. So we'll write it underneath. So we've got -infinity all the way up to -2, and that's going to be a bracket because of the closed circle. Then we jump, that's our union, open circle at 2 all the way to +infinity. Now that I have it written in interval, let's translate that into set builder. So we have x such that, now -infinity up to 2 means I want all of the values less than -2. That's basically shading to the left. Remember, shades to the left means less than. Then I'm going to do or, because that's our union, 2 to infinity. Well, that's the low number, so that means I want all the x's greater than 2. And then close off the bracket. Sometimes interval is easier to start with. Now let's do range. So ranges are y's. That means bottom to top. And again, take one section at a time. So the left section, my lowest I get to go is that arrow, which means -infinity. That's the lowest. For my left section, the highest is this curve, which is actually right at 0. And because it's a solid line, it'll be a solid point. So let's shade everything in between here. That's my left section. Now let's look at the right section. My lowest point on the right section is, again, that little U shape. So we're going to, that's a solid point right here again at 0. So now we've got two overlapping points. Now, this is not the highest point. My highest point is this arrow that will tell me to go up forever. So look what happened. All of my y values overlapped each other. There are no gaps here. So my range is negative infinity to infinity because there are no gaps in between. We filled in everything. Even this circle got filled in because of this solid point or solid line. So what we really have for set builder then is we're going to have the fancy bracket y such that we've got infinities on both ends. That means this is all real numbers. So y is an element of the all real numbers. Start with one section at a time and see if they'll overlap each other, because they might. So now I've got 7, 8, 9, and 10 that I would like you guys to pause this video and try on your own. When you're ready, unpause it and you can see the answers to all 7, 8, 9, and 10. So here are your solutions for 7 and 8. Domain is in the blue on the graph and range is in the Y. Here are your solutions for 9 and 10. The domain is in blue and the range is in red.